Okay, recording's on. Remember that we were solving this equation right here?
Yeah.
And we had this problem because we needed to get rid of the A matrix so that we could have the x and the y by themselves. Now, wouldn't it be nice if we had something we could multiply this by and it would go away? As I was saying, wouldn't it be nice if we had something we could multiply this by and it would go away? Well, if you want to get...
My bad. Yeah, come on, let's go. Is it recording?
Yeah.
All right, I hope so.
So as I was saying, you want to turn this into a 1 or an I. What could we multiply by that would turn this into an I? I'll give you a hint. It rhymes with Schminverse. That's right. So what you're going to do is you're going to take both sides here. You're going to write just a little bit of algebra on the side. You're only going to need to write this once. If you have A times x is equal to b, what you do is you take both sides and multiply by the inverse.
You don't divide me.
There is no division with matrices. There is only multiply by the inverse. And so right here, inverse times A is going to give us I. You relate too.
Yeah. Well.
You get that, right? But I multiplied by anything just gives you that thing back, right? Say right.
Right.
So this side, the I times x, is actually just x. So if we want to know what x is, we take the B matrix, which is right here, and we multiply it by the inverse of the A matrix. Now, since the A matrix is right here, first thing we need to do is find the determinant of A. So we're going to do 3 times negative 6 minus 5 times negative 2. Negative 18 plus 10 gives us a negative 8. Step 2, write your inverse matrix. Bless you.
Thank you.
So your inverse matrix, remember, is 1 over the determinant. Here's our determinant, so we grab that, pick it up, plug that in right here. Okay. We've had a lunchtime to forget. Do you remember what goes here, 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 and here?
Yes.
Not the A, the A and the A and the B. Is that what you said?
Yeah.
No.
Yeah, the A and the B.
Okay. So we flip the A and the B, and then we change the signs on the C and the B. So we're going to get negative 5 and negative 2. Okay? I mean positive 2. Thank you. All right. Now you can see that in a second we're going to have to take this and multiply it by B. So I think it's probably easier if we leave the fraction out for now. Okay? So our answer, our x, which is really x, y, the x that we've got right here is really a matrix, xy. We were lazy, so we just wrote it as x here, but it's really that. Okay? Is going to be equal to the inverse, which is 1 over negative 8 multiplied by negative 6, 2, negative 5, 3, multiplied by the B matrix, which is 20, 36. So let's do this calculation here. Here we go. Negative 6 times 20 is going to give us negative 120. 2 times 36 is going to give us 72. Take out your calculator if you haven't already. Negative 20 plus 72. What does that give us? Is that 92? No, negative 120 plus 72. It's got to be smaller than that. What is that? 52. Okay, take that. Are you sure it's 52? It's not 52. 48 sounds right. Okay, so that gives us negative 48, right? Take that negative 48, you got to divide it by this because of the 1/8. So negative 48 divided by negative 8 gives us 6. Right here. Negative 5 multiplies to 20. We get negative 100. 3 times 96 gives us, what is that? 108. So we get negative 100 plus 108. What does that leave us with, folks? 8 multiplied by 1 over negative 8 is going to give us negative 1. Therefore, x is equal to 6 and y is equal to negative 1. And if you look at the problem when we solved it earlier,
Whoa, that's,
x is 6, y is negative 1.
B so much more
I
complicated.
like the other method better.
Yeah.
Sorry.
Okay, I think you're going to like this method in a minute.
Okay.
Okay? And by a minute, I actually mean in 10 minutes.
You got 10 minutes.
You got 10 minutes.